Data types part 2. In this session, we learn about the variables and the type of variables, the construction rule of variable, then storage class specifier. Variables, the quantity change while the program is execution is called variable. The construction rule of variable is common for all data types. Each and every type of constant has unique construction rule. But in variable, it is a common construction rules to construct the variable. The variable name is any combination of 1 to 8 alphabets, digits or underscore. A variable name is any combination of 1 to 8 alphabets, digits or underscore. In modern compiler, it accepts up to 40 characters, But all compiler accept, it may be a world compiler or a new compiler, it accept up to 8 characters. That character should be the combination of alphabets, digits and underscore only. No other special symbol allowed. The first character must be an alphabets. The name of variable, the first character should be an alphabet. No commas or blanks are allowed. Except underscore, no other special symbol allowed. SI underscore int, M underscore HRA, symbol interest, monthly, house rent allowance. So if we want to separate a two word in a variable name, we use underscore. No other symbols allowed to construct the variable name. The construction rule is common to construct all type of variable. The time of variable declaration, it has different type and size. For example, integer qty, tot. So qty, dot is a two variable. So it is an integer type. The construction rule is common for all data types. Float, price, sell, choice. So the price, the construction rule of float variable price, the construction rule of integer variable quantity, the construction rule of character variable choice are all same. Up to 8 it accept up to 8 characters. That character may be a alphabets, digits or underscores. No special symbol allowed. The first character must be a alphabets. So this is the common rule to construct the variable. If we declare it is an integer, so it allocate 2 bytes for qty. So it accept the value within this range. If we declare as float, the price is occupied 4 bytes, it accepts real values, real constant. Choice is a character, so it occupies only 1 bytes. We can assign any one of character from ASCII chart. In English, the noun is user defined, but verb is predefined. We cannot use verb as noun. In such a way, we cannot able to use these keywords as variable name or function name. So this each and every keywords has special meaning in compiler. So totally 32 keywords available in C languages. By using this keyword, we make a statement. Based on the statement, compiler understand our requirement. So the keyword is similar to the verb in English. Storage class specifier, it's define the storage area and some characteristics of variable. At the time of the invention of C language, the size of memory is very low in computers. That is, at the time of invention of C languages, all computer has limited memory, that is low memory capability. That is main memory. So we want to utilize the memory in better way. So the storage classes are introduced to handle the memory management. So it has four types: automatic storage class specifier, static storage class specifier, register storage class specifier. The final one is external storage class specifier. So that storage class specifier specify the characteristics of variable. What are the characteristics? That is four characteristics. It specifies the four characteristics of a variable. What is the requirement to specify? To utilize the memory efficiently. So it has four types. Each and every type of specifier specify four kind of characteristics. One is memory, default, life, scope. So memory, if you declare a variable, that variable requires some bytes based on the type. So it needed to allocate a memory. That memory is two types in C languages. Usually in all computer languages, the memory memory allocated for variable in main memory only. That is a RAM memory. In C languages, we can also allocate memory in CPU register. That is default value. What is the initial value of that variable? If we declare a variable, just we declare variable, it allocates some memory for that variable. But we are not assigned the value, just we declare the variable. If we assign the value, it holds that value. We write a statement for declaration, it's allocate memory only. If we assign the value to that variable, that value is stored into that memory. If we not assign the value to that variable, what is the value? That is the initial value. For example, integer a semicolon. What is the value of a? It may be 2 value. It may be any one of 2 value. One is garbage, another one is 0. So based on the storage class specifier, that specified variable as 0 or garbage value. If we declare a variable in a function, if we enter to the function, that variable is the life started. If terminate from the function, the life of variable is come to end. Life has two life, global life, local life. If we declare a variable in a function, we can access that variable within a function. If we come out the function, the memory of the variable released. Then we enter to the function, then it create new memory. So each and every function call, the memory of variable is created, newly created. This is local life. If we call a function, it uses one variable, it allocates some memory and assigns some value. We come out the function, then we call the function. It continues the same memory. This life is global. We discuss through program in next slides. So life has two types. One is local, global. Scope also has two types, local, global. Scope of variable is, we declare a variable within a function, we can access the variable within this function only. If we try to access the variable in out of the function, if the accessibility is possible, the scope of variable is global. If we access that variable in out of the function, that is in other function, that scope is global. If we access only within a function, the scope is local. Auto, if we declare a variable using automatic storage class specifier, the memory is RAM. The default value is garbage value, that is unpredicted value. If we assign a value, that value is assigned to that location. Before assigning, after declaration, before assigning a value, the default value is unpredictable value. If we declare as auto, that is garbage value. The life is local. If we come out the function, it releases the memory. Then again it come to the same function, it create new memory location. That is local life. The life is local. The scope is local. If we declare a automatic storage classifier variable within a function, we can access that variable within this function only. We cannot access that variable in out of the function. So the scope is local. If we declare a static storage class specifier, if we declare a variable in static storage class specifier, so the memory is RAM. The default value is 0. If we assign a value, that value is assigned to that variable. The before assigning, after declaration, the default value is 0. Life is global. If we declare a static variable in a function, if we first call the function, it creates memory. If we release the function, it will not remove the location. If we re-enter the function, it uses the same memory location. In same memory location, the previous value stored. This life is global. So, in static global life, but local scope. We can access the variable within a function only. We cannot access the out of the function. So, register. If we declare a register storage class specifier, by using register storage class specifier, we declare a variable. So it occupies memory from CPU register, that is processor, microprocessor has some register. Based on that size, we call that processor as 32-bit, 64-bit, 16-bit processor. If 64-bit processor, the microprocessor included 64-bit memory for internal operations, that is CPU register. But at the time of invention of C language, that CPUs are in 16-bit processor only. Currently we are using 64-bit. And the invention of C, at the time of invention of C, the computers has 16-bit processor. The desktop computer has 16-bit processor. So we can allocate 2 bytes from register by using register storage class specifier, but we can allocate only 2 bytes. That is only one integer variable. We cannot able to allocate 2 variables by using register storage class specifier, because register has only 2 bytes. The default value garbage, life is local, scope is local. Then the external storage class specifier, the memory is RAM, default value 0, life global, scope global. So if we need this specification, we can use auto. If we want to access the variable in out of the function, we use external. So storage class specifier is help to utilize the memory in efficient way. Default value. This is a program to illustrate the default value. Here we declare integer a. This is a external storage class specifier declared variable. This is a external declaration. We declare before the main. This is external variable, integer a, main. Automatic storage, by using automatic storage class, integer b, auto int b. By default, all are automatic storage class specifier. If we declare integer b or auto int b, both are same. The default storage class specifier is auto. If we declare auto int b or int b, both are same. So auto int b, we allocated 2 bytes from RAM memory. The default value is garbage value as per the previous table. The memory is RAM. For automatic storage class, the memory is RAM. Default value is garbage value. The memory, the scope of variable is local. life of variable is local. Here static integer C. In static storage class specifier, C allocate location from RAM memory. The default value is 0. But life is global. Scope is local. This is a register storage class specifier. So it allocates memory from register because CPU register has only 16 bit at the time of the invention of C language. Nowadays it is 64 bit. But at the time of invention of C language, all computer has 16 bit processor. So it occupies only 16 bit. That memory is integrated in with CPU, that is processor, microprocessor. So it allocate only 2 bits, register D. It allocate 2 bits from CPU register. The default value is garbage. The life is local. Scope is also local. This is a external storage class specifier. We declare before the main function, this is external storage class specifier. We don't put extern as a keyword here. Just we declare int A. This is the external storage class specifier. So it occupies 2 bits of memory from RAM. The default value is 0. The life is global, scope is global. So what is the output? Here we declare it. We don't initialize the value to these variables. Just we declare it. If we print that values, it print only default value. So A equal to B equal to percentage C. So what will this is the output, A equal to 0, because A is a external storage class specifier. So the default value is 0. B equal to minus 3 to 4. This is a unpredictable value. This is garbage value because B is a automatic storage class specifier, specified variable. So this is garbage value. Static, the default value is 0. Register D. D is here. The default value of C is D is default value of register is garbage value. This is also unpredictable value. This program illustrates about the life of variable. Main function. So it called display function. Then it again called display function. This is the definition of display function. And display function we declare as auto int A equal to 5. Just we put int A equal to 5, this is equivalent to auto int A because the default storage class specifier is auto int A equal to 5. At the time of execution, it starts from a main, it control there is a function called, it control transfer to main display function, then it allocate 2 bits memory. The default value is garbage value, but here we initialize it. So that 5 is assigned to A. The value of A is 5. Printf. Here we display 5. It will display 5 only. So after the printf, we add 10 with existing value of A. This existing value of A is 5. 5 plus 10, 15. That 15 is assigned to A. Now the value of A is 15. 15. Then the control is transfer to main. Again it called the same display function. The control transfer to display function. Then it declare, because the automatic storage, the life of automatic storage class specifier is local. If we enter to the function, it create new memory. So display 5 assign 15. It come out this function, the memory released. The time of exit the function, the memory automatically released. So the value also removed. Then again it call the same function. Then it create 2 bytes memory for A. It is a new allocation. It does not have any value. Then it assign 5. Now it also print 5. Then it changed to 15. The control transfer here, it terminate the program. The output is 5 only. So first time it enter, it create a memory. At the time of exit of the function, it remove the memory. The values are also removed. Then again we call a function, it create memory, assign, then we print, it increase. At the time of exit, remove the memory and values also removed. So 5 5. In this program we declare as static. Here we declare auto. If we declare as static integer a equal to 5, the same program, the storage class specifier is only different between this program and this program. This one is auto, this is static. Static integer a equal to 5. The first time it called the function, so it allocate memory, RAM memory. So the assign value 5 to a, then display 5. It change into 15. 5 plus 10, 15. The value of a is 15. If at the time of exit the function, it does not remove the memory. It does not remove the memory because the life of static is global. The time of exit the function, the memory does not remove. The value again stored in that memory. The value remains in a. Then control transfer to main function. Then again we call the function display. The control transfer to here. Then static integer a equal to 5. So it is not create new memory the second time. The first time it create, assign the value, change it as 15, come to the main, then it transfer. Again we call the display function, it transfer, but it uses the same memory location. This is already in a, it has 15. In previous function call, the value of a is 15. So it display 15. First call it display 5, then it changes 15. The memory is not removed at the exit the function, at the time of exit the function. So then we call the function. It will not create a new the next time. It will not create the new memory at the entry of next time. So it uses the same memory. The value is 15. It display 15. Then it changes as 15 plus 10, 25. The value of a is 25. It control is transferred to main. It terminate the program. The output is 5, 15. This is life of variable. Scope of variable. Integer a. This is a external variable. External variable, the characteristics of external variable, that is memory is, what are the characteristics of external variable? Memory is RAM. Default value is 0. Life global, scope also global. That is main. Integer b equal to 10. This is a automatic storage class specifier, because the default storage class specifier is automatic. Integer b equal to 10. So then we assign a equal to 5. We can access the a because it is a global declaration. We can access a in all functions. So a equal to 5. Then we call display function, the control transfer, display a. This is valid because we can access this external variable to all function. We can access the variable in all function. So here we can access, we assign a value to a. This is valid. Here we get the value from a. This is also valid. But here we cannot able to get the value of b because b is a local variable to main function. This is local variable to main function. So b can access within this function only. We cannot access out of the function. So this is invalid one. Because a is valid, because a is the external variable. The scope is global. But int is the automatic storage class based variable. The scope is local. So it can access within a function only. So it causes error because it is undefined variable and display function.